The last 2 days, we learned about comparative relational thinking and how it is about balancing and not solving. So we want to know the reason why we could balance equations to make them true rather than just solving and knowing why it's true or false or finding the unknown. So now what we are going to do is we are going to move on comparative relational thinking with multiplication. So our first example is 2 times 8 equals 4 times 4. So multiplication is similar to adding, where we have to use opposite operations. So one of these I'm going to have to multiply to make the same, and the other one I'm going to have to divide to make the same as the other side. So I'm trying to balance this left side with this right side. So if I look at the relationship between 2 and 4, I know that 2 times 2 will give me 4. Then if I look with the relationship between 8 and 4, I know that 8 divided by 2 will give me 4. This is a balanced equation because I used opposite operations, multiplication and division, and I came up with the same equation as the other side. So 4 times 4 equals 4 times 4. Let's do another one. Okay, the next one will be 6 times 5 equals 12 times 10. So I'm going to see how this left side compares to the right side. Remember this, I need to use opposite operations, so I'm going to use multiplication and division. 6, and I'm going to find the relationship of it with 12. 6, I know times 2 will give me 12. Okay, now I'm going to see if I multiplied this side by 2, that means I have to divide this side by 2. 5 divided by 2, I cannot get an answer. That is not going to be a full answer. And I know that 5 divided by 2 does not equal 10. So I put NA here because that means not applicable. So that means this problem is going to be false because 5 divided by 2 does not give me 10. Now let's do a couple where we solve for a variable. 3 times 4 equals 6 times n. Remember, a variable n, letters are used in math to represent numbers when we are trying to find out what they are equal to. So I'm going to try to find out what n is equal to by balancing the equation, not solving it. So I'm going to say 3 times what or divided by what gives me 6. Because this is a larger number, I know I have to multiply. And I know 3 times 2 will give me 6. So if I multiplied this one by 2, I have to use the opposite operation, dividing. And divide by 4, 4 divided by 2 will give me 2. So I think n equals 2. We could check our work by saying 3 times 4 equals 12. 6 times 2 would also give me 12. So we balance this equation by using comparative relational thinking. Let's just do one more of those types with the unknown. So this problem will be 35 times 5 equals 7 times n. So this one might look a little bit difficult right now because we don't know off the top of our head what 35 times 5 is. But if we use comparative relational thinking and balance the equation, it will be much easier. So 35, I want to get to 7. I know that 7 times 5 will give me 35. So that means 35 divided by 5 will give me 7. Next, if I divided this one by 5, I have to multiply this one by 5. 5 times 5 equals 25. So I would say n equals 25.